5.2, the derivative of y equals b to the x. So yesterday's lesson was on y equals e to the x. Derivative of e to the x was simply e to the x. But b to the x is just a little bit different. In your textbook, you would have gone over, maybe in class, finding the constant of proportionality. And in that exercise, what you were doing was finding, or you used a program to find the actual slope of the function of, say, 2 to the x when x is minus 2. And then you divided that derivative by the value of the function at minus 2. And you found out that the numbers were all the same. And for 2 to the x, you would have found it was about 0.693, which happens to be the ln of 2. If you do that whole exercise again with 3 to the x, you would get a different number, which happens to be the ln of 3. So it ends up that the derivative of b to the x is b to the x times the ln of the base b, which is the constant of proportionality for the derivative here. So another way of looking at, which I think makes a little bit more sense and is easy to follow, I'm going to do for you over on this side. If we said that b to the x was the same as e to the ln b to the x, so remember that if these two things are the same, so e and the ln of e, this is your solution, right? So this is true. And then using the ln of logarithms, I know that this is the same as x ln b. So if I take the derivative of that using what I already know about the derivative of e to the x, I'd say the derivative is e to the x ln b times the derivative of the exponent, which is the ln of b. So going back, tracking here a little bit, so b to the x was e to the x ln b. So this is just the derivative with respect to x of b to the x. And this is b to the x as well. And we get the same equation that you got using the constant of proportionality. So what I'm going to do is some examples for you, finding critical values as well as we go along. So let's take a look at some basic ones first. 5 to the x, we already know that that's going to be b to the x ln b. So you should say this to yourself while you're doing your homework, right? B to the x ln b, b to the x ln b. And that way it'll help reinforce what you're doing as you're going along. So the second one here, y prime, is going to be 3 to the 4x. You just write the same thing out. Right, look, it's a very same. And now the ln of the base, which is 3, and the derivative of the exponent, which is 4. So a few things to note here. Make sure you do not make this the ln of 12. That is not the same thing. And neither is it the same thing for you to multiply 4 times 3 here, as I'm sure you're fully aware. Those are like really bad math mistakes. So 4 times 3 to the 4x ln 3 is your solution. It's always nice to write it with the ln at the end. So let's take a look at a quotient rule here. So I have x squared over 2 to the x. So here we go. We're going to do the Hodihi rule, also known as the quotient rule. So ho, which is the bottom, times the derivative of the top. So d high, ho d high, 2x, minus high, d ho. So here we go. This is a new one. 2 to the x ln 2. All over ho squared. Okay, so before you go and try to expand this, let's take a look if we can simplify. And remember that you're always simplifying about this minus sign. So whatever is a common factor here that you can pull out of the numerator and divide out with the denominator. I have a 2 to the x, a 2 to the x, and I had 2 of them down here. Sounds like an auctioneer. So what am I left with here if I have this left? So what's common on both sides here still? So looking for something common, I would say I have an x on both sides. So I'm going to pull out that x. So I have x times 2 minus x ln 2. That's all I have left. And in the denominator, I have 1 2 to the power of x. So if I asked you, For critical value, you'd say, okay, well, for critical value, set y prime equal to 0. Remember that you're looking with y prime is 0. That means where is the slope horizontal, where is a maximum or minimum. That's why we're doing these. And so I set y prime to 0. For y prime to be 0, it only matters what makes the numerator 0. Recall that. You can't divide by 0. So what makes this 0? 0. So x equals 0. And what makes this 0? So I would say 2 minus x ln 2 is equal to 0. X ln 2 is equal to 2. X is equal to 2 divided by the ln of 2. Okay, so I have two values for x that make this 0, and I'm going to figure out whether or not they're minimums or maximums using a first derivative test. I call it y prime, and I label the two critical points, 0 and 2 over ln 2. You want to get an understanding of where this is on the number line, so you can do that on your calculator. 2 divided by the ln of 2, remember this is just a constant, and you should get approximately 2.9, which is close enough for me to do. I have to check these three zones to see if this function, the derivative function, is going to be positive or negative. That tells me the slope, right? The slope in each of those zones. So if you're a fan of the chart method, you'd say, well, I need to check x, I need to do 2 minus x ln 2, and I need to do 2 to the x, and I need to know what this comes out to be. Okay, so if I put in -1, this will be negative. Let's pick some numbers. We're going to pick -1, 1, and 3. So -1, 1 would be positive, 3 is positive. Now I need to know what 2 minus x ln 2 is. So the ln of 2, let's just take a look at what the ln of 2 is here. Let's just ask the calculator, what is the ln of 2? Ln of 2 is 0.69. So if I put 1 here, so that's 2 minus 0.69, that's going to be positive. And 2 to any power is positive. We can make all these positives right away. To the power of -1, to the power of 1, to the power of 3, all positive numbers. If I put in positive 1 here, 2 minus 0.69, that's also going to be positive. And 2 minus 3 ln 2, 3 times the ln of 2 is going to make this larger than 2. That will make this negative. You can try it if you don't believe me. And so my final solutions here are going to be negative, positive, positive. That's negative, 3 positives, and a negative. So that means we have negative slope, negative slope. So now that we know that this is going to be minimum value, because we're going like this, right? So minimum, therefore, minimum at 0, and I need to know what is the function when x is 0. I have 0 divided by 1, so 0, 0, and a maximum at, now don't put in 2.9, you put in this, okay, because that's the exact value, 2 over ln 2, and plugging that into your calculator here, squaring it and dividing by 2 to the 2 ln 2, 2 divided by ln 2, you should get approximately 0.5633. I could be off on that. I did it kind of in a hurry, but basically it's just a plug and chug thing. Okay, so let's go on to another example. And I have a product rule. So I have 2x times 2 to the x. So I'm going to do the product rule. So I'm going to do first times the derivative of 2 to the x. So that's 2 to the x ln 2. First times the derivative of the second plus the second times the derivative of the first, which is 2. And there's my product rule. Now I'm going to look for common factors. So I have a 2, and I have a 2 to the x, and I have 2 and 2 to the x here. This is the hard part, right? So 2 times 2 to the x. Do not multiply those together, whatever you do. So that's my common factor. And what am I left with if I take out 2 to the x? I have x ln 2 plus 1. Okay, so for critical values, set y prime equal to 0. And I would get x ln 2 is equal to minus 1. So x equals minus 1 over ln 2. Make sure you leave the lns in, okay? Okay, question number 5. For an example, we have something a little different in that we have the radical or the square root of 3 to the x. And I would rewrite that as 3 to the, remember this is x and then to the half power. So it's to the 1/2 x. So that makes it much easier for you to take the derivative. Okay, so maybe you might want to stop and try that one, but I'm going to keep going because I know you can pause, but I got to keep on rolling here. So I'm going to use quotient rule. So I'm going to do ho, d high. So the derivative of this is, write it out, right? 3/2 x ln 3 times 1/2. And I'm going to subtract high, which is 3 to the 1/2 x, d ho, which is 2x, all over the derivatives, the denominator squared, which is x to the 4th. So again, pause, take a look where your minus sign is, look for common factor, generally here, right? So I have an x, I have 1x, and I'm going to make this 3. Common factors now, what can I take out of both sides here? Well, I have 3 to the 1/2 x, right? This one and this one. And remember, it's about this on both sides of the minus sign. So I'm going to take out 3 to the 1/2 x. And what am I left with? I have a half, 1/2 x ln 3 minus 2. Okay, so you could have also taken out a half. I'll write that one here just for another example. You're still going to get the same answer, right? If I take out another half here, so I would have a half times 3 to the 1/2 x. So far, so good. And in here, I would just have x ln 3, and 2 divided by half would be minus 4. Now, it doesn't matter. If you didn't take that half out and you had to set this to 0, you would still get the same solution, right? So if I want to solve for this, I'd say for critical values, don't forget, set f prime x equal to 0. Hopefully when you're doing your tests, you hear my voice telling you to do this, right? 4 is equal to x ln 3. So x is equal to 4 divided by the ln of 3. Okay, so that was example, what are we doing here? Example 5, and everything looks good. Okay, so let's take a look at this because I wanted you to note the difference between the e to the x and derivative of e to the 3x and y equals 2 to the 3x. So y prime here is going to be e to the 3x times 3, right? So we had 3e to the 3x. Now, if you did the same thing as b to the x, you would have said e to the 3x ln 3, ln of e, right? E to the 3x ln 3 times 3. And the ln of e, which, I mean, you could do that way. Let me just show you again back over here. So I would have 2 to the 3x ln 2 times 3. So this is my constant of proportionality. And in this case, the ln of e is 1. Right? So this is equal to 1. So that's why e to the 3x, and we know that's a very special one, so it's just the derivative of itself. Okay, so I just wanted to just really remind you that if you have e to the f at x, y prime equals e to the f at x times f prime x. This is just restating what you should already know. And y equals b to the f at x gives you b to the f at x ln b f prime x. Write that out a few times and that'll help you. Okay, the last thing I want to do is a word problem from your textbook. It's number 6 on page 240, and it asks you determine the half-life. So it's a radioactive decay question. Percentage left at time t is given by this equation. Determine the half-life and how fast is it decaying when it's at its half-life. In other words, they want to know the rate of change, how fast something is decaying. That's your derivative. Determining a half-life, that's logarithms, right? That's going back to advanced functions. So determine the half-life. We're solving for t. Solve for t, right? So if you want to know the half-life, you say, okay, well, when do we have 50%? If this is 100, when is it at 50? So you can start it like this. You could just even set it equal to a half. Okay, so I divide by 100, and I get 1.2 to the minus t. So remember, to solve this, you're going to take the log of both sides. So the log of 0.5 is equal to minus t times the log of 1.2. And that means that t is going to be equal to the negative of the log of 0.5 divided by the log of 1.2. And that's going to give you a time of approximately 3.8, and this is years. I didn't say that, but it was years. Okay, so now that I know that this is the time, I want to figure out what is how fast is it decaying, means I need the derivative. So I'm going to be trying to find p prime at 3.8, but let's just find p prime at t first. So the derivative of 100 times 1.2 to the minus t is 100 times 1.2 to the minus t ln 1.2 times minus 1. Okay, so we had to keep the 100 in there, but we do the 1.2 to the minus t ln 1.2, so the ln of the base, and times the derivative of the exponent. So p prime, I guess we could straighten this out just a little bit. We could put the minus out front here. Doesn't really matter. Let's do p prime at 3.8. So that would be negative 100, so minus 100 times 1.2 to the minus 3.8 times the ln of 1.2. And I haven't calculated that, so we can bring in the calculator. So it's decaying, so our answer should be negative, and obviously it's going to be. So I have minus 100 times, remember with calculators, you've got to use a lot of brackets, right? 1.2 to the power of bracket minus 3.8. I'm going to put an equal sign there, okay, and then times the ln of 2. Oh, not 2, 1.2 equals minus 9.12 approximately. So that means it's decaying at 9.12. I think I didn't have the question brought up here, but I think it was grams per hour, maybe. You'll have to look that up yourself. I don't have the textbook open. It happens to be on a. Let me see if I can find it quickly here. It's years and percentage p. Oh, so it's just a percentage. So you're losing a 9.12, therefore losing 9.12% per year. at 3.8 years. Okay, don't forget you need units for these kinds of questions. Okay, so that's 5.2 for you. Just a little note for you that I had to do this lesson 3 times because I had some technical difficulties, not to mention the fact that I have a cold. I hope you love it as much as I loved doing it for you. All the best, guys. I know you're working hard. Keep working. Bye-bye.